Okay, we're going to work on these expressions involving simplifying rational expressions. And those that involve multiplication and division, it's really all the same process. If you happen to have a problem that involves division, you just simply multiply by the reciprocal of the second term. So for example, if we were going to do 2/5 divided by 7/10 back in the day, we would do 2/5 being multiplied by 10/7. And we'd be looking to simplify something. And of course, you might recognize that the 10 and the 5 can reduce, but the reason they can reduce is because that 10, we've got 2/5, and that 10 is made up of a 2 and a 5. And so anything that's a common factor in the numerator with a common factor in the denominator, we can cancel out. So we can cancel out this 5 with this 5, and then we just proceed from there. And once we've reduced everything possible, we multiply across. 2 times 2 is 4, and 1 times 7 is 7. So of course that's a numeric example, but it's the same idea when it gets to rational expressions involving algebraic examples. So notice in number 7 your final answer is x over 2x. Well, that's a common factor of x that's in both the numerator and the denominator. So we could take this a little further and cancel out that x with this x, and your final answer would be 1/2. So that's the final answer for number 7. Now for number 8 down here, looks like we've got 9x squared over 4 being multiplied by 8x plus 8 all over 18x. So the first thing we want to do is factor any expressions if possible. And I recognize that 8x plus 8 has a common factor of 8 in it. So we could rewrite this as, for number 8, 9x squared over 4 being multiplied by 8 times the quantity x plus 1. And in the denominator we have an 18x. And of course 18x has a factor of 9 in it. So they always rig these problems, so there's some things that we can reduce. So if I wanted to fully factor these things, you could see the 9x squared is really made up of a 9 and an x and an x over that 4, which we could think of as 4 times 1, and then the 8 we can think of as 4 times 2, x plus 1, and then the 18x in the bottom as a 9 and a 2 and an x. And now we just start picking off things that are common factors. So we can pick off this 9 with this 9, that 2 with that 2, this x with this x, this 4 with this 4, and sure enough, the only thing we have left in the numerator is an x and an x plus 1, and in the denominator we have simply a 1. So depending on how your teacher wants your answers, whether she wants them, or he or she wants them in factored form or multiplied together, we could take that numerator and distribute the x in and get x squared plus x. And since our denominator is 1, we don't really need to put it. So that'd be the final answer for number 8. 9 looks like it's, I think it's all good there. The x squared minus 5x plus 6 has been factored. X squared minus 4 goes to x minus 2 and x plus 2, x minus 3. I think you got everything taken care of there. Yeah, it looks pretty good to my eye. And it looks like you kind of stalled here on number 10. Might want to just start this one from scratch with what we have here. Let's take a look. We have 4x, that's number 10. We have 4x over x squared minus 25. I always like to factor the terms as I rewrite it. So for example, x squared minus 25 becomes x plus 5 and x minus 5. And then we're multiplying that by an x minus 5 in the numerator. Keep parentheses around that to remind you that it's one quantity. And then denom, we have this 8x squared plus 20x. And we look at that and say, can it be factored? And the short answer is yes, because there's a common factor of 4x in both of those terms. So we could take a 4x out, and we'd be left with x plus 5. And one thing about factoring, you can tell you're right, because, I lied. It wouldn't be x plus 5, it would be 2x plus 5 in there. And you can tell you're right because when you multiply back in, 4x times 2x will give us the 8x squared, and 4x times 5 gives us a 20x. So looks like we've got some stuff to cancel out here with everything being factored. I'll put an equal sign, and I will reduce this 4x with this 4x, and an x minus 5 with this x minus 5 up here, leaving only a 1 in the numerator because everything got canceled out. And we will just proceed. So we'll say we have 1 over x plus 5, and then the denominator 2x plus 5. And if you want to multiply that all together in the denominator, we're going to get 2x squared. You're going to get 15x's and 25. So that would be my final answer for 10. We can continue and knock out 11 and 12. Then hopefully you'll get a sense of how to go about these things. The key is just simply the factoring. If you can get the factoring done correctly, the rest is just pretty straightforward. So we've got x squared minus 9, which you have as x plus 3, and x minus 3. And then 5 in the denom. In the numerator, we have a 10, which I'll write as a 2 times a 5 to show the factoring, and an x plus 3 in the denominator. So we can cancel out an x plus 3 with an x plus 3, a 5 with a 5, and we are left with simply 2 times x minus 3 in the numerator, and a 1 in the denom, so we just leave it as 2x minus 6. So there we go. And it looks like the last one down here, let's see here, we've got 6x plus 12. Well, I recognize that both 6 and 12 have a common factor of 6 in them. So I'm going to write that as 6, for number 12 here, 6 times the quantity x plus 2. Then our denominator is 5x, 5 and an x. That's being multiplied by 10x, which would be like a 2 times a 5 times an x. In the denominator, an x plus 2. And now we can start picking off the common factors. X plus 2 goes with x plus 2. 5x goes with 5x. The only thing that's left is all in the numerator. So we have a 1 in the denominator. 6 times 2 is 12. And so you can just rewrite it as 12. So there you go. The key with all of these problems is making sure you get things factored correctly. And you can tell these textbooks are all rigged so that you get lots of things to cancel out. A little bit of a trap here and back in number 10, when you take out this common factor of 4x, you were left with 2x plus 5, not an x plus 5, so nothing to cancel with that one. But again, it's all about if you can get the factoring done correctly and rewriting them carefully and just sniping, canceling out any common factors that exist in the top and the bottom. These problems are pretty manageable. So there you go.